I'm going back to a recursive formula, like, for example, problem 18. Can we start? Okay. So problem 18 on page 752. And that is A1 is given to us, and A sub n is given as 3, an minus 1, of course, for n greater than or equal to 2. Because A1 is already given to us. So starting with the second term, we will use a recursive formula. The first term is given to us. So the same question here, we need to determine the first 4 terms. We already have the first one. Now let's determine the second one. How do we do that? Say it again. Okay, I'm ready. Just dictate and I'll write it. Yes? Times 5 minus 1. Very good. 15 minus 1 is 14. Excellent. A sub 3. 3 times 14 minus 1. Very good. So I think that this is 42 minus 1. Is it 41? Correct me if I'm wrong, please. So 41. And what about the last term? A4? Good. So 123 minus 1 is 122. So how will this sequence look like? Something like this. 5, 14, 41, 122, 3 dots. 3, an minus 1, and 3 dots. Any questions on this? Any questions? The last type of problem that we want to look at in this section is, for example, we are given the following sequence, 49. It's the sum. 1 over 2 plus 2 over 3 plus 3 over 4 plus dot, 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 plus 14 divided by 14 plus 1. They're asking us to come up with a summation notation for such a sum. Now, the first question is, which index would you like to use? You can invent one. You don't have to use I, J, K. It's up to you. But just give me an index. Which one? Very good. Good. So let's take a look. Let's look at the sequence. Let's look at the sum. Look at the general. This is kind of the general term because it's the last one, right? So look at the last term and tell us what is the general term here, depending on J, of course. And how far does it go? What is the upper limit? The lower limit? The lower limit is 1. Excellent. What do you think about the upper limit? What do you think? Okay, so let's take a look. 1, 2, 3. What was it? 14 it is. Good. From what? I need an expression here so that when J is 1, I get 1 over 2. When J is 2, I get 2 over 3. When J is 3, I get 3 over 4. And when J is 14, I get 14 over 14 plus 1. So can we come up with a general term? Exactly. J over J plus 1. Let's verify this. When J is 1, do we get 1/2? When j is 2, do we get 2/3? When j is 14, do we get 14 over 14 plus 1? Very good. Let's take a look at the next one. Let's say you can choose anything you want. I'm looking at 51. 4 plus 4 squared over 2 plus 4 cubed over 3 plus 3 dots plus 4 to the n over n. Again, they want us to come up with a condensed form of the sum using, of course, the summation notation. Say it again. I couldn't hear you. Lower limit should be 4. No. Say it again. No. Yes. So let's say k from k equals 1 through so 1, 2, 3, n. From what? We will verify in a minute. Because when k is 1, I have to get the first term. When k is 2, I have to get the second term, etc., etc. So then, what is the general term? And it has to be in terms of k, of course. Four to the first power, 4 to the second power, 4 to the third power, 4 to the nth power. 1, 2, 3, n. Yes, 4 to the k over? Indeed. Now we verify just to make sure. So when k is 1, do we get the first term, 4 over 1? Yes? When k is 2, do we get 4 squared over 2? Yes? When k is 3, do we get 4 cubed over 3? And finally, when we get to n, when k is n, do we get 4 to the nth over n? It takes a little while till we, get accustomed to this. So don't expect it to come in. Okay, here's the next one. 52, right? So it takes a while. That's why we practice. 1 over 9 plus 2 over 9 squared plus 3 over 9 cubed plus dot, dot, dot plus n over 9 to the nth. Oh, this is the third example. Now this should be a little bit easier now. Use the index you like and tell me from where it starts and where it's going. Say it again. Yes, so which index you'd like to choose or use? Okay, from j equals 1 till? Yes. Obviously, all terms are fractions, so I have to have a fraction. Otherwise, I would not have a fraction. But all terms are a ratio. So what we have at the top? Good. At the top is j, because when j is 1, I get 1. When j is 2, I get 2. When j is 3, I get 3. And when j is n, I get n. And what do we have in the denominator? 9 raised to j. Let's check again. When j is 1, we have 1 over n. When j is 2, we have indeed 2 over n over 9 squared. When j is 3, we have 3 over 9 cubed, etc., etc. Is that clear? Yes? Okay. There is nothing else I can teach you from this material. It's all done. So let's go back to our now you're experts if you want to come next semester and teach. I'll be very happy. So let's start with the end since we just finished this. So we all have this form, correct? Yes? 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 Okay, ready? So let's start with the end and we'll see how this will take probably less than 2 minutes. Okay. So let's start with what we just finished a second ago. So let's look at the sum. So we're asked to find the lower limit, the upper limit, and the general term. Okay, so 1, 3, 5, ... 2n minus 1. Which index we want to use? It doesn't matter. Say it again. We cannot. That's one that we cannot use. We cannot use the index n. Say it again. B. B is fine. So from B equals. I'm sorry? Yeah, it's I, J, K normally, but my friend Z said B, so we have to comply now. She said B. I can't say no. Good. From B equals. We're talking about the lower limit. Not the general term just yet. Okay, 1 till. Okay, it appears to be n, but now what is the general term? You mean the general term has to have, the general term cannot have anything else but numbers, operations, and b. Please don't say I, do not say n, do not say j. Okay, so what is it? There is no fraction. Of course. 2b minus 1 indeed. Because when b is 1, we get 1. When b is 2, we get 3. When b is 3, we get 5. When b is n, we get 2n minus 1. That's it. Okay, let's simplify this. N plus 1 factorial over n factorial. Which one is bigger? Is it n plus 1 or is it n? N plus 1. So then we start there. We leave n factorial alone. And what we have at the top? N plus 1. We have to start with what it is in parentheses. Times n, not enough. Thank you. And now we simplify, and the answer is n plus 1. So obviously these two problems take less than a minute if we know what we're doing, right? Okay, so let's go back to, here it is, recursive formula. We're asked to find 4 terms. Can anyone give us the first one? The first term is 4, sorry. Good. Can anyone give us the second term? And the recursive formula is 3 times the previous term plus 3. Yes? Excellent. What is the next term? So 3 times 15, 45, 45 plus 3, 48. Is this okay? 3 times the previous term plus 3. 3 times 4 is 12 plus 3 is 15. 3 times 15 is 45 plus 3 is 48. And the last one, 3 times 48 plus 3. So 48 times 3 is 48 times 3 is n plus 3. Good. Okay, so let's go back to number 24. And 24, we are given the general term. So now, whenever I'm given the general term, if you ask me to determine a sub 100, I can just plug in. But with a recursive formula, I cannot. So if you ask me to find a 1,000, which means n equals 1,000, I can't. I have to go step by step and determine each and every one of them till I get to 1,000. Here it's not a big deal. If you want me to find a 1,000, I'll replace n by 1,000. I'll give you the answer. Okay, so a sub 1 is 1 plus 1, so it's 2. So the top is 1. 3 squared is 9. 9 minus 1 is 8. So in the general formula, or the general term, I replace n by 1. Now I replace n by 2. 2 plus 1 is 3. Negative 1 to the third power is negative 1. And 3 squared is 9. 9 minus 1 is, I'm sorry. Yes, indeed. 9 minus 1 is 8. Was the first one 8? No.
Yeah,
how did I get that?
It was 1.
1. So 3 minus 1 is 2. Sorry. So the first term is 1 over 2, and the second one is negative 1 over 8. What about 3? 3 plus 1 is 4. Negative 1 to the fourth power is positive 1. And 3 to the third is 27 minus 1 is 26. And now the last one. I don't have enough room there, so I'm going to write on the side. 8 sub 4. 4 plus 1 is 5, so the numerator is negative 1. And 81 minus 1 is 80. Okay, we do have one more. Use a calculator's factorial key to evaluate. So we can't determine this by hand, so we have to put in the calculator. So let's do just that. So 40 factorial, remember the factorial is in math, and go to probabilities and choose 4. And divide by 450. I think it's 450. Yes, it is. Okay, now be very careful with this number. It ends with E and 45, which means times 10 to the power 45. It's a huge number. So we're going to write 1 dot or 1.81 times 10 to 45. So 1.81 times 10 to the 45th power. I'm sorry? Excuse me? Oh. But we know how to write that. Okay. Any questions? Any questions about sequences? Any questions? Okay, so let's go back then. We will review again on Monday, sequences, whatever you need from those. Okay, so let's go back here and let's choose what we want. Would you like to go back to Gauss-Jordan? Have we looked at this problem before or not yet? I'm sorry? Have we looked at this one? Okay, I was asking about this one. So should we do it or not? That's all. That was the question. Yes? Okay, perfect. So let's start. So we have x plus y plus z equals 0. X minus y minus z equals negative 4. X minus y plus z equals 2. The first concern I have is whether the system is presented in the correct order. Correct order means x below x, y below y, z below z, equals symbol below the equals symbol, and the free term below the free term. And yes, it happens that this system is already set up as I wanted it to be. Now in the next step, I will do what? The augmented matrix. Excellent. So here it is. 1, 1, 1, 0, 1, negative 1, negative 1, negative 4, 1, negative 1, 1, 2. So we have the augmented matrix. And what happens next? There is no need because I already have 1 at the top. This is done.
Yeah, but if you switch it, you'll have 1 second and 1 on the third row already.
Say it again. You want to switch the first row with the second row?
That's what I was thinking.
Everything will change once you multiply. So that's why it's hard to look ahead. It's a very good point you're making. It's hard to look ahead. It's not like a chess. You know, you have to see the fifth move once you start move one. No. Everything will change once we multiply and add with the second row and the third row. Okay, perfect. So we're going to use which row now? Of course, always row 1. What do we multiply row 1 by to add it to row 2 and then to add it to row 3? It happens that in both cases we have to multiply by? Indeed. Good. Which row do I copy? Because in this step it will not change. Indeed. The questions I'm asking every step are annoying at some point in time because I repeat them all the time, but this is what I'm hoping that you will remember what to do. So that is the next question, right? I found what I need to multiply by to eliminate those numbers under 1, but at the same time, I need to remember that the line that I use, the row that I use, does not change, and I have to copy it. The other two will change. So 1 times negative 1 plus 1. Perfect. 1 times negative 1 minus 1. Perfect. 1 times negative 1 minus 1. Excellent. 0 times negative 1 minus 4. Excellent. Let's look at the third row. 1 times negative 1 plus 1.
0.
1 times negative 1 minus 1. 1 times negative 1 plus 1.
0.
Excellent. 0 times negative 1 plus 2.
2.
Very good. So all this is done. Where am I now and what am I doing? What do I need to do and where am I? Yes. So this is my focus right here. What do I have to get in there, in that box?
Multiply by 2.
But if I multiply by 2, I get negative 4. Divide by?
Yeah, so
By?
negative 2.
By negative 2 indeed. So at this step, we divide row 2 by negative 2. Okay, what do we get? I copy the first row. I copy the third row. And 0 has to stay. If I destroy the first column, I'm going backwards. Yes. So what do I have here? And here? And here?
2.
Excellent. So I accomplished this. Now I want these to disappear. Which row am I using next? It must be row 2, indeed. Very good. So I multiply row 2 by something to add it to row 1, and row 2 by something to add it to row 3. What do we multiply row 2 by to add it to row 1 and eliminate that 1? By? I will not work. 1 times negative 2 plus 1 will not be 0. So what do we need to multiply this by to eliminate this? Good. And what do I need to multiply this by to eliminate this?
2.
Very good. Which row do I copy next? Because I know it will not change. Yes, because I'm using it. 0, 1, 1, 2, and of course the first column cannot change in any way. If it does, we're in big trouble. Okay, so let's do this together. 1 times negative 1 plus 1.
0.
1 times negative 1 plus this one. 2 times negative 1 plus 0.
Negative 2.
Well done. 1 times 2 minus 2.
0.
1 times 2 plus 0.
0.
1, 2 plus 0, 2. 2 times 2. 4 plus 2.
6.
Where am I now and what am I doing?
4.
In row 3, what should I do?
Divide by
Divide row 3 by 2 indeed. Awesome. I copy everything above, both rows, and divide row 3 by 2. 0, 0, 1, 3. Since this is already 0, we only need to multiply row 3 only once to add it to row 2. Nothing needs to be done to row 1. So what do we need to multiply row 3 by to eliminate this number? That's the last one in our way. By negative 1. I copy row 3. I also copy row 1. And I only have one step. 1 times negative 1 plus 1.
0.
3 times negative 1 plus 2.
Negative 1.
So I'm hoping. I have no idea. I have to go back and check in the original problem. It's so easy to make a mistake. So I'm checking negative 2, negative 1, 3. Ready? Yes? Heather, are you okay? We got something else?
No.
You may be right. Till we check, we don't know. So negative 2 minus 1 is negative 3 plus 3. Okay. Negative 2 but plus 1 is negative 1. Negative 1 minus 3 is negative 4, yes. Negative 2 but plus 1 is negative 1 plus 3 is 2, yes. So now we know for sure, and no one can find another. And I'll say this is it. Definitely. The solution is the triple negative 2, comma, negative 1, comma, 3. Okay. Did we get the idea about Gauss-Jordan? I mean, we'll review it again next week, but is this okay so far? Okay, so let's continue. Let's see what is left on this page. So here we have to graph the solution set of the following system of inequalities. That's 1. Then we want to solve the system right here. Solve the system. And this is find the length and the width of a rectangle whose perimeter is and whose area is. Which one do we continue with? We have to look at all of them, so it doesn't matter. So please choose, or I will. Okay, I'll choose the system first. So we have x plus y equals negative 11. And x minus 3, everything squared, plus y plus 6, everything squared equals 34. So we're asked to solve this system. Is this a linear system? Is it a nonlinear system? Is it a linear system? What type is it? Can anyone tell us what is the first equation? What type?
Isn't the equation also?
The first one, what type it is? Linear, of course. What about the second one? It's a circle, yes. Very good. It's a circle with a radius the square root of 34 and the center 3 comma negative 6, correct. So the system is a nonlinear system. It has a linear equation and a nonlinear equation. So there is no way I can eliminate. I don't have the same variables. So my only hope and my only chance is to do what? Substitution. Very good. So you have to solve either for x or for y from the first one. So which one would you like to solve for? Very good. So x will be negative y minus 11. In that case, we will replace x in the second equation by negative y minus 11. So let's do that. So negative y minus 11 and minus 3 will be negative 14. Everything squared plus y plus 6 squared equals 34. Okay, now what? How do I solve this equation? What is the first step I need to perform? Say it again. So what will you do? What will be the next step from here? Yes, or expand. Yes, of course. That's correct. But I prefer not foiling because we know the special product, but it's up to you. It's a precious formula, so this is extremely important to not to continue foiling, especially if you want to make progress in math from here to some other course. Okay, so the first term squared plus 2 because they're both negative, so everything will be positive, plus 2 times the first times the second. Of course, y plus the second term squared. Same thing with the second one. So plus y squared plus 2 times the first times the second plus the second term squared minus 34 equals 0. So 196 and plus 2 is 198. Combine like terms, 2y squared plus 40y plus 198 equals 0. I think that's what I got. Because 36 minus 34 is 2. So 196 plus 2 is 198. Okay, so I'm looking at this equation. What type is it? Quadratic. Very good. Awesome. Thank you. What do you think we should do first for sure? Yes, but since it's an equation, I can already divide it. I cannot divide by y or x or a variable, but I can divide by 2 and get rid of it. So y squared plus 20y plus, is it 99 equals 0? Now, you don't have to worry about this. You don't have to factor it if it's too long. If it takes more than 30 seconds, forget it, right? So y equals negative b plus or minus b squared minus 4ac divided by 2a. And I'll put in my calculator, negative 20 and plus the square root of 400 and minus 4 times 99 and divide everything by 2. I got negative 9 as one answer. And I copy and I change the positive into negative in front of the square root. I override that. I got negative 9 and negative 11. So y equals negative 9, y equals negative 11. This is good, but it's not good enough. I have to go back and determine x. So what is x for the first one and what is x for the second one? So negative 9 with minus in front will be positive 9. 9 minus 11 will be negative 2. And negative 11 with minus in front will be positive 11. Minus 11 is -2, -9. And 0, -11. Is this okay? Yes? Good. So we solve the system. So this system has two solutions. We should always go back and check. Always. Unless you're running out of time on the test situation, which is not going to be the case, I hope. You should not go back and check, but we should always go back and check. Okay. So we continue. Find the length and the width of a rectangle whose perimeter. So we have a rectangle. So I denoted the length by x and the width by y. And we are told that the perimeter is 34 feet. And the area is 60 square feet, of course. We're asked to find the length and the width of this rectangle. How many variables we have in this problem? 2. How many equations we have to write? Excellent. I'm waiting for you to come up with 2 equations. Yes, 2y plus 2x equals? And xy equals 60. Excellent. Well done. Good. How do we proceed? How do we solve the system? Substitution, elimination, which one? I will recommend simplifying the first equation both sides by dividing both sides by 2. So I have x plus y equals 17. And then xy equals 60. We cannot use elimination. The variables are not the same in the sense that this is a product and this is not. So I recommend substitution. Let's solve either for x or for y, the first one. Which one?
X.
Very good. Negative y plus 17. All I have to do is just plug it in. So negative y plus 17 multiplied by y minus 60 equals 0. In descending order, negative y squared plus 17y minus 60 equals 0. And you already know what I am going to do next. What do you think I am going to do next? You know me quite well by now. Say it again. I will get rid of the negative leading coefficient. Yes, and then the quadratic formula. Absolutely. However, this is not difficult to factor, right? Negative 12 and negative 5. Y minus 12, y minus 5. The product is positive 16. The sum is negative 17. So we have y equals 12 and y equals 5. It's good, but it's not good enough. We have to determine x. So we go back to negative y plus 17 with 12. How much is x if y is 12? Perfect. And how much is x if y is 5? Indeed. Correct. Okay, so then the two ordered pairs, two possibilities. Yes, 5, 12 and 12, 5. So it doesn't matter which one is 5. It can be the length or it can be the width. Very good. Any questions so far? Okay, we'll completed this page. So let's go back now to the next one. I think we should jump. We'll complete everything, of course, but let's continue with 17 for now. A logistic growth model for world population f of x in billions, x years after 1982. What does that mean immediately? I have to put it in writing so I don't forget. What does that mean? X years since 1982. It means that 1982 represents x equals
X.
for someone born in 1982. X years after 1982. What is the person's age in 1982? 0. So we are given f of x equals 12.57, 1 plus 4.11 e to negative 0.026x. According to this model, when will the world population be 8 million? So x is the number of years since 1982, and this is in billions. This is the world population. So the question is, we looked at a similar problem, not an easy situation at all. When will the population, so what is x when the population is 8 billion? We are already 7 billion and growing. But the question is, when will the population be 8 billion? And f of x is in billion. We don't have to put the zeros. So when will the population be 8 billion? So what do I need to write? So where is our starting point? Yes?
A.
Indeed, yes. That's why we should write everywhere on paper when we solve a word problem. Take notes. This is the number of years. This is in billions. This is the population. So I don't forget what variables represent. Now you will say, how do I solve this? Exactly. That's exactly what I was going to say. Forget about the noise you see in the denominator. It's a proportion. At its core, it's a proportion. So we will cross multiply. So this parentheses this equals this times 1. So you can put 8 over 1, and that's, we cross multiply. So 12.57 equals 8 parentheses 1 plus 4, 11 e to negative 0.026x. Okay. So I changed it from a proportion to a product on the right. Okay. Remember, I need like peeling an onion. I need to peel everything slowly, step by step, to get to this. So I want that to disappear, this to disappear, this to disappear, and just get E in there. So I want this to go away now. How do I make this go away? Exactly. And do not divide, just keep it as is. 12.57 over 8 equals 1 plus 4.11 e to negative 0.026x. Now I want 1 to disappear. Subtract 1. So 12.57 over 8 minus 1. keep it like that. Equals 4.11 equals times e to negative 0.026x. Now I want this to disappear. So I peeled off the 8, then I peeled off the 1. Now I want to peel off the 411. How do I peel that off? What is the operation between these two? Right. So then how do I get rid of it? Excellent. So then I have e to negative 0.026x equals 12.57 over 8 minus 1 over 411. Do not bother with this. This is just a number. We'll get to it later. Okay, so it's completely cleaned up. Don't look at this. It looks ugly, but it's just a simple number. Okay, so now I have e to negative blah, blah, blah equals a number. What is our next step? How do I proceed? Indeed, there is nothing else I can do. Natural log to this side and natural log to that side. Notice that I intentionally don't want to calculate this, because if I calculate, then I have to approximate it when I plug it in natural log, and that's what I want to avoid. So this becomes negative 0.026x equals natural log, and be very careful how you write this. Natural log is in front of the fraction line, the denominator is this, and the numerator is 12.57 over 8 minus 1. Okay, I peeled off everything. I just have one more slice, which is divide both sides by. Yes, Alex, go ahead.
Oh, no, so sorry.
Negative 0.2.
Yes, that's it. That's the last step. So I want x. Now be very careful how you write it. The whole thing gets divided by negative 0.026. Fraction line and the equal symbol have to be lined up. The numerator is natural log of a fraction. In the denominator of the log is 411, and then 12.58 over 8 minus 1. Now this is a mess to put in the graphing calculator. You have to be very careful. So number one, I will have parentheses. Number two, I will have parentheses around the numerator. So first of all, I will have parentheses for the log. Then I will have parentheses for the numerator. And then I will have parentheses for the denominator. So let's do this together. So I'm going to put them in so you can see them here. Parentheses here, parentheses here, parentheses here. For the graphing calculator. Ready? Okay. Natural log. It pops up with parentheses already. Another parenthesis, and I have 12.58 divided by 8. Outside of that, minus 1. Close the parenthesis. Divide now by 4.11.
12.57.
It's 5.7. It was 5.7? I wrote 5.8 all the time.
5.7, yes.
Oh,
No, it's 5.7.
okay. I like changing things. Sorry, thank you for catching that. My apologies. Okay, so I go back and correct. Seven it is. So I divide by 4.11. Now I close the parenthesis for the numerator and divide in parentheses by negative 0.026 close. It was only 1 0, right? Yeah.
Yeah.
Okay, so now I press enter. 75.89, I can round it up to 76. What does this mean? So x approximately 76. But it's 76 years since 1982. So that will mean what? If I add 76 here, I get 8502. In the year 2058, if the population will still follow the same model, that part I don't know and I can't tell.